What's the most sophisticated and expensive way to go insane? Do you know? An ingenious plan perfect for someone who's decided to end it all in the most spectacular way possible? You don't have to look for options in the Darwin Awards top list. Those ways aren't there. We're talking about the upcoming colonists' flight to Mars. But why are we mentioning this great event in such a pessimistic way? Because in this case, optimism is not only undesirable, but also fatal. The aforementioned one-way journey is unlike anything humanity has ever done before. It holds dangers, the full list of which we are not even roughly familiar with. Compared to this space adventure, having breakfast in a cage with wild tigers is just an ordinary meal. But enough with the prelude. For Earthlings, Mars is beautiful and still the most suitable candidate for colonization. What challenges await astronauts on their way to the desired goal? How much time will astronauts have to spend in deep space? Is it possible to solve most of the problems that arise during a long flight? And the main question is, who will reach Mars first, humans or creatures with the intelligence of an eggplant? Let's try to answer briefly. And essentially, Hubble. Subscribe. So, why the red planet? That's the simplest question out of a huge number of them. The conditions on Mars aren't exactly hospitable, but at least its clouds won't shower colonists with sulfuric rain like on Venus. A day here lasts almost as long as on Earth, and there are changing seasons. However, a year itself is twice as long as on Earth. The weak gravity of the red planet also works in our favor. The weak gravity of the red planet and the thin atmosphere offer just a little protection from cosmic radiation. The conditions aren't paradise, but they're not quite hell either. However, let's not count our chickens before they hatch. A manned flight to Mars is still just a planned event. So let's focus on the journey itself. Do you know why we mentioned eggplants at the beginning of the video? Because the greatest and unfortunately not unfounded fear of scientists around the world regarding the flight to Mars is that even after reaching the red planet, astronauts might not be able to land on it. Not to mention establishing a colony and conducting scientific research. Why? Because after several months of flight, the crew members will turn into constantly vomiting patients suffering from Alzheimer's disease, like those in a dementia ward. This isn't meant to scare you. Scientists at the University of California, Irvine, found through experiments on laboratory rats that prolonged exposure to charged particles similar to cosmic radiation causes irreversible cognitive impairment in the brain and malfunctions in the central nervous system. It is noteworthy that the rats were bombarded with charged particles for only 6 months, and the results of this exposure turned out to be extremely disastrous. And yet astronauts will have to travel to Mars, possibly for 9 months or even longer. Why did we start with the cognitive sphere? Because radiation is the main danger threatening astronauts both in open space and on Mars itself. Accordingly, it is radiation that can primarily lead to the complete failure of the mission and the death of the crew. To be continued. Space radiation affects not only brain function, it destroys the DNA of living organisms, causes irreversible mutations, and leads to a painful death. The effects of radiation on humans under Earth conditions serve as a distant example of such destructive changes. Recall the devastating effects of the United States strikes on Hiroshima and Nagasaki, or the Chernobyl nuclear plant explosion. But cosmic ionizing radiation has gone through many stages in this regard. We haven't even talked about the other problems of this extremely complex and deadly journey yet. An analogy can be made with the first spacecraft that tried to land on the surfaces of neighboring celestial bodies. Out of ignorance, engineers equipped them with insufficient protection and didn't take into account a number of other factors, as a result of which the probes perished, either in the atmosphere or within a few seconds after landing. But can a flattened tin can, even if it's not cheap, really compare to human lives? That's why scientists approach the organization of a manned mission to Mars with great caution, and preparations for it involve the work of all groups of specialists, from quantum physicists to candidates of medical sciences. How do scientists plan to solve the problem of radiation exposure? The condition of astronauts on the International Space Station cannot serve as a marker in this case because they are protected from invisible death by the Earth's magnetic field. It makes sense that an interplanetary shuttle also needs protection. The crew will need medications that protect astronauts from developing cancerous conditions and other problems. Solar flares also matter, especially if at least one occurs during the flight. In that case, the manned mission to Mars could end with the entire crew dying from radiation sickness. However, there is also some encouraging news. Scientists are not giving up and are looking for ways to protect astronauts on their difficult journey. A computer simulation has been created based on data from the Curiosity rover, where astrophysicists tried to model how shielding technologies would work in Martian conditions. The results were encouraging. It turned out that cosmic rays are well reflected by composites made of synthetic fibers, certain types of plastic, and rubber. But this still doesn't solve the problem of radiation during the flight, since you still have to get to the red planet through the void of space, which is filled with invisible killer particles. In any case, research on producing effective protective components for the interplanetary shuttle continues. Next in line are the anti-radiation vest from the Israeli company SteamRed, the high-efficiency particulate air radiation monitoring detector, and the development of a powerful electromagnetic field by specialists from the European Center for Nuclear Research. What aids scientists' research? A powerful supercomputer, which also offers the concept of an active non-magnetic screen. What is meant is an electrostatic field. Right now, astrophysicists at National Aeronautics and Space Administration's Jet Propulsion Laboratory are working on it. What is the next problem that future colonists will face? It's the lack of gravity. Again, the International Space Station crew can't help with this issue, since they're in microgravity, which only remotely imitates Earth's gravity. Gravity is one of the basic influences on the human body that determines its function and operation. The absence of this invisible force leads to a radical restructuring of all systems, starting with the cardiovascular system. In weightlessness, the heart has to work much harder to pump blood, which mostly flows to the upper half of the body. At this stage, a malfunction occurs because the brain thinks there's an excess of fluid in the body and starts releasing the corresponding hormones to solve the problem. That's just the tip of the iceberg. Oberg sees it as a minor issue solved by adjusting the drinking regime. Things get much worse when the state of weightlessness becomes chronic and prolonged. That's exactly what awaits astronauts during a flight to Mars. When preparing the crew, genetic predispositions of team members must be considered. Bone loss leads to bone fragility. In weightlessness, bones become porous and weak and muscles atrophy. Everyone has seen footage showing the arrival of cosmonauts on Earth, where instead of brave conquerors of space, helpless people return home, who, like little children, have to learn to walk again. What does this mean? It's necessary to create both an artificial gravitational and magnetic field. The absence of the latter negatively affects the human autonomic nervous system. It also protects the surface of the celestial body or spacecraft from ionizing radiation. In this regard, certain problems arise. For the magnetic field to be effective, its range must extend to 100 kilometers in diameter. In that case, the electromagnet would be so huge and massive that installing it would make the mission itself impossible. In addition to artificial gravity, specialists have developed alternative ways to protect astronauts from diseases. For example, taking medications that reduce the risk of illnesses caused by weightlessness. But what about the psychological barrier? Is it possible that under the conditions of total cosmic radiation, Alzheimer's disease might not even occur? A shuttle could reach Mars with a crew that has destroyed each other. The crew will be thoroughly tested for stress tolerance during a long journey in a confined space, as well as for compatibility. But the possibility of conflicts arising still can't be ignored. The slightest aggression, like a match in an oxygen flask, will immediately trigger an explosion. To this, you should add exhaustion, injuries, insomnia, and the inability to properly treat aggravated illnesses. And most importantly, the distance from Earth, which will be felt even more strongly the deeper the ship travels into space. And if the equipment suddenly detects a strange sound coming from the void, how will the astronauts react to that? We'll leave that question open. What do scientists plan to do about the possible psychological problems of the crew? It is proposed to equip the shuttle with virtual images of changing seasons, to liven it up with earthly sounds, the noise of the sea, bird song, and so on. What if we put into practice Aldous Huxley's scenario, a gram of soma and no drama? In other words, use tranquilizers? There's nothing new about that idea. Back in 1983, a nootropic drug called phenotropol was developed for Soviet cosmonauts, which could rapidly restore cognitive functions and improve psycho-emotional state. On the International Space Station, it's mandatory. A medical kit, which includes temporary fillings, antidepressants, nootropics, stimulants that increase physical activity and performance, and antiemetic agents. Obviously, the contents of the medical kit for long-term space travel will be seriously revised and improved. The only thing that doesn't work in space is a mercury thermometer, but you can check your body temperature using the spacesuit, which monitors vital signs. Finally, we've listed all the problems during the flight. I wish I could say that, but it's not true. What other threats await the crew of a ship that's leaving for Mars forever? Assuming the flight and landing go smoothly, the red planet itself won't welcome the colonists with open arms either. Mars is quite a hostile environment, not meant for humans to stay in without protective habitats. Think about it. Mars rovers almost immediately find Martian dust inside after landing. So what would happen to human lungs in such conditions? And how well will the equipment in the colonists' modules function? And that's not even mentioning possible critical equipment failures, both during the flight and on site in extremely low temperatures. Mars averages highs of minus 60 degrees with poles reaching minus 150 Go. It's a questionable pleasure, the need to constantly wear a pressure suit, since Mars's atmosphere is barely there, and its pressure is less than 1% of Earth's. In addition, despite the compensating effect of the thin atmosphere and regolith, the radiation level on the red planet is 2.5 times higher than on the International Space Station. And the colonists will also have to solve this problem. Right now, the Perseverance rover is testing the innovative Mars Oxygen in situ resource utilization experiment device to produce oxygen from the Martian atmosphere, which will greatly help future missions, since, if successful, it will support the operation of the modules. It is planned to install dust filters to neutralize the harmful effects of Martian storms. Who is currently willing to invest in this venture? Which companies are preparing manned missions to Mars? Among the global projects is the century-long spacecraft, which will land colonists on the red planet, and then continue on to one of the star systems. Inspiration. Mars Foundation is a company planning a manned flyby of Mars, and Mars One is a rather risky private project that will broadcast what is happening. Of course, we can't fail to mention the promising plan of Elon Musk, which is being developed by SpaceX. What do you think? Will any of these projects ever succeed, and when will it happen? Maybe you have ideas on how to keep astronauts safe during extreme flights. Share them in the comments.